Okay, so here's the standard B2A2, and what they want you to do is calculate for an object moving in one dimension the velocity change that results when a force f of t acts over a specific time interval. So what does that exactly mean? Well, before we get into that, what if we have a function for acceleration and we want to know what the velocity of that was over a specific time interval? So let's say I have a equals 3t squared plus 6t minus 2. How do I determine the change in velocity from 1 to 3 seconds? Well, remember that the definition of acceleration. Remember, acceleration is defined as a change in velocity over change in time. So we're going to place a with dv dt. Now we have to think of what we need to get v by itself. So we, in essence, want to just multiply both sides by dt to get that out of there. And now we have dv, so to get just v, dv is, think of it as a tiny piece of v, and the way we get v is we have to add up all those tiny pieces, and to add up, that's where we do the integral. So we have to do the integral of the left side and the right side. We're going to integrate over the limits from 1 to 3 seconds. And let's just review our integral equation. Integral equals ax to the n. So what is the integral of that? Remember that we want to add 1 to our exponent and divide by our new exponent. So then we have to carry that through. So remember that integral of dv is just v. And then we need to follow our rules on the next. So we have add 1 to the exponent, divide by the new exponent, 3t to the 2 plus 1 over 2 plus 1. Or you could have had 3t cubed over 3. Plus 6t 1 plus 1 over 1 plus 1, minus 2t to the 0 plus 1 over 0 plus 1. Remember that there's a hidden t to the 0 there behind the 2. And again, we're evaluating that from 1 to 3. So that becomes v equals t cubed plus 3t squared minus 2t from 1 to 3 seconds. And when I put the 3 in there, I get 3t cubed plus 3t squared minus 2 times 3. And then we put the 1's in for the t's, and we get 1t cubed plus 3 times 1 squared minus 2 times 1. And then we evaluate that, and it becomes 48 minus 2, or the change in velocity is 46 meters per second, which is good. But remember that that's not what the standard asks. The standard wants us to know, what if we're given a force? So let's change this to force. And if we're given the force, then they probably are going to give us the mass as well. And the reason why is because we need to think, how can we get acceleration from force? Well, remember that Newton's second law says that F equals ma, so A is force divided by mass. So what we can do is take this force equation and just divide it by mass. And we take each term divided by that 2 kilograms. And what that results is an acceleration equation. F over m equals A, and then we can divide by 2, and we get A is 1.5 t squared plus 3t minus 1. And then remember from what we just talked about, a is dv dt, and from there we can solve for the delta v. So why don't you go ahead and finish this off and put your answer that you get into the answer box.